Okay, so now we're going to cover chapter 8, so networking and communication basics of the computer systems. So you have a lot of objectives, so take a look at those and make sure you can define what these are. So, what is a network? It is defined as two or more objects sharing resources. So information are interconnected computers, terminals, or servers connected by communication channels. Devices other than computers are networks. So you have printers, scanners, barcode readers, what we covered in the last PowerPoint. So devices that can be shared to save money and space for users. So looking here, this is an example of how computers are all networked together. So network classifications, they're by geographic classification. So there's the LAN and the WAN. So there's the local area network and the wide area network. So with the LAN, so small area is networked with a series of cables or wires. The computers can share information and devices on the same network, so it's less expensive to install. It's much faster than a WAN, W-A-N, and larger networks are composed of several LANs interconnected to create the WANs. So PACs and archives, so PACs, workstations in a radiology reading room would be considered a LAN. So computers are interconnected and communicated by passing images and reports. So with the wide area network spans a large city or area, state or nation, continent, or the world. So a WAN is used to connect computers that are not physically attached. So they're connected through other means, so telephone lines, satellite links, or other communication cables. So there's long distance communication links. They're expensive, and often these communication links are owned by separate companies. So you can see here you have your LAN and how it's connected, and then you can see here, and you can use the WAN to connect the two different systems. So network is determined by the following. So role the computers play in operation of the network. Which computer controls the network operations? So two typical components. Role classifications networks are the following. So there's peer-to-peer and server or client-based. So peer-to-peer network, so each computer is networked is considered equal. It controls its own information and operation, and a computer can function as a client or a server. So most popular network for small offices or home configurations, as it's less expensive and simple to set up. This is what we have in our house. With the server-based network, a centralized computer or server controls the operations files and sometimes the programs of the computer or clients attached to the network. So the server provides a location for storage and retrieval of the network. So it allows the users to move from computer to computer to access their files from a central location. So this is what we use at Mesa College. So I'm able to log on to any computer and access all my, well, most of my files. So how it works for the server-based, the client requests a file, the server sends the entire file to the client for processing, the client sends the entire changed file back to the server for storage. The network follows or allows a lower end computers as the clients with one expensive high-end computer as a server. So the server is a really strong, powerful one. The network can have multiple servers, so the network must have one dedicated server that controls it all, though. The radiology PAC system is an example of this type of network. So in your hospitals, the PAC system is the big monster. So client-based network, so similar to the server-based network, a centralized computer controls the operations. So the server processes the resource as requested by the client, so the server returns only the results back to the client. So smaller exchange of information cuts down the load on the network. The network allows for more room for other requests. Typical components of a network, so those computers, there's three types of computers found on the network. So there's servers, thin clients, and thick clients. Each of the three has a specific purpose and a mission on the network, and you'll need to know what those are. So if we look here, we have a server, and we have the workstation, and then we have clients. So this will give you an idea kind of how it flows. So the server, it manages resources for other computers, servers, or network devices. May also house application, provide storage for files, manage various other network tasks, most often dedicated to one single task for the network. Usually the most robust computer on the network, maybe one server that provides storage for files and one that manages the print functions, and another may provide internet access for the network, so you can have multiple servers. Thin client, it's a device found on a network that requests services and resources from a server. It's called the thin client. So maybe another computer or printer or other network device that needs that server to complete its tasks. Almost any PC can be a client as long as it can be attached to the network. So what is a thick client? A computer that can work independently from the network. So it can process and manage its own files, networked so it can share resources such as printing and take advantage of the additional security available through networks through dedicated servers. It's generally a high-end computer that does high-level processing for specific purposes. Specialty application workstations most often found cross-sectional imaging modalities where three-dimensional imaging is used to aid in the diagnosis. All right, so network connectivity, so communication medium. So devices are connected via some sort of communication medium. The physical connection between the device and one of the following four types. So there's the coaxial cable, the twisted pair cable, the fiber optic cable, or electromagnetic waves. So when we talk about the coaxial cable, I'm sure a lot of you guys remember this from years ago, where we used to have to take the TV and actually screw it into the wall. We still have that currently. It consists of a center conducting wire surrounded by insulation and grounded shield of braided wire. So it shields and minimizes electrical and radio frequency interferences. So the coaxial cable is the sturdiest wire used, often found in the network infrastructure throughout the building. So you'll see that all over. The twisted pair wire, so similar to the telephone wire, except that the telephone wire only has 4 wires. So it consists of 4 twisted pairs of copper wire. So wire is insulated and bundled together with an RJ45. Wires come in various levels of quality and capacity. The minimum recommended standard is a Cat 5. So you hear the Category 5 cable, so you'll hear the IT people talk about a Cat 5 line. So that's what they're talking about. Why this wire is the most common connection for LANs. Fiber optic cable. So it uses glass to transmit the data. So it consists of fiber optic core that is surrounded by plastic protective coating. It's a lot faster than metal, but is more expensive and more fragile. They had it running under our carpet and we ran over it with the chair and broke it. So it didn't work anymore. It's easily damaged by kinking and twisting. So a lot of the MRI cables are the fiber optic cables, and people would wind them up really tight and break all the fiber optic glass lines in there. So you have to be very careful with these, as they do break very easily. So wireless connections. So connections made by using infrared or radio frequencies. So no physical cabling is needed. You have to have a wireless transmitter and receiver. The biggest advantage is mobility and convenience, but connection has a limited range. So if you have thick walls, as we know, our cell phones don't work well in the classroom because of all the lead-lined walls. And the further you are from the point of frequency, the worse your signal is going to be. So your network interface cards here, and what they do is they provide physical connection between the computer and the network medium. So it works with networking software to establish and manage the data, to chop up the data into packets, and to handle addressing issues. So plugs directly into the motherboard as an expansion card. So A network hub, the simplest device for connecting several pieces of equipment, has several wiring ports available to receive and pass data to various connecting pieces of equipment. So the network switch is similar to a hub, but it sends the data only to those devices which the data are directed. So it reads the destination address from the data and selects a path that is straight to the intended target. Reduces the network traffic, so that's good, and it speeds up the overall network connection, which is great, and it makes the network more efficient. So it's not usually used in small offices or applications. There's no need for it, but in larger facilities it is. So a network bridge. It's created so that the larger networks can be segmented to reduce traffic. So segments can then be connected with a bridge. So a bridge is a physically wired connection from one network segment to another. So it can recognize in which segment a particular destination address resides and send data directly to it. So bridges can also bring two or more networks together that speak the same language, which is nice. So a router. It's a little more sophisticated. It can read portions of a message and direct them to their intended target, even if the target is on a separate network and uses a different network protocol. So the router helps with segmenting the network to allow access for only approved devices within that segment. In large network, multiple routers, switches, and hubs work in concert to perform the necessary tasks. So, network communications, devices communicate via NIC through the communication medium. Data is sent to a destination address of appropriate targets. So each computer on the network is assigned a unique address. So we call it an IP address. This address is a combination of the physical address of the computer hardware and the node address given by the network. So one type of addressing is IP, so the Internet Protocol. So the IP address, what is it? Address is made up of 4 ocklets, so groups of 8 bits of numbers. So the numbers range from 0 to 255, such as 144, 162.21, 104. The first set indicates the network class. The rest of the numbers tell the other devices its exact location. So when we say we checked your IP address and you're not at that hospital, it's because the location, we found out that that's not the IP number for that location. So that's how we can track you, geo-track you. So data travels along the network using an agreed upon set of rules known as the network protocol. So protocols send data in packets from one device to another. So a packet is a piece of data with added information such as the IP address, the source address, the sequencing of the packets, and errors in transmission. So protocol is delivered in layers of communication known as protocol stacks. So each layer of communication represents a particular aspect of the network function. So typically a network communication is explained using 7 layers of the open system interconnection models. A simplified model consisting of the bottom 4 layers are needed to understand the basic network communication. So layer 4. So this is the transport layer. It ensures that data packets are sequenced correctly, ensures that they do not contain errors. The third layer breaks up the data into little frames. So the layer decides which network path the frames will take to their destination. Layer 2 is the data link layer, and layer 1 is the physical layer. So it consists of the networking media and the components required to pass on the signal from one end of the network to the other. This is the layer that actually moves the bits from one place to another. So the layer 1 moves them from one to the other. Layer 2 is your data link layer, and 3 breaks it up into little bite-sized pieces, and 4 is also transport. So, okay. Network topology. So topology is the physical geometric layout of the connected devices on a network. So there's 4 common configurations. There's the bus, the ring, the star, and the mesh. So all devices are physically attached for the bus to and listen for communication on one single wire. This wire is a single point of failure. If there is a break, the entire network goes down. So some communication can take place between the computers on either side of the break. Business networks does not need any switches or buses. So, I'm sorry, the bus network does not need any switches or hubs, which is nice. So the ring, devices are connected in a circle. So each device passes received messages to the next node on the ring, always in the same direction. So data transmissions move around the circle until they reach the correct receiver. If there is a break at some point in the ring, the entire network stops. Token ring. So computers are connected in a circle like a ring. When the computer is ready to send a transmission to another computer, it picks up an empty token as it passes by and fills it with the message. So as a token passes the other computers, the destination address is read by each passing computer and is ignored if the IP address is not right. So when the address is found, the data is deposited and the token is now free again. So if another computer wishes to send out information but the token is occupied, it must wait until the token becomes free before it can transmit. So this can slow down the whole system. The star, devices are connected to a central hub or a switch. The data is sent through the hub to the destination device, so the transmission might go through another hub or switch to the network or directly to the device. This is the most common network topology used. So this is what it looks like. This is the star, and this is very common. So each computer, it goes through a hub and then gets routed wherever you need it to go. The mesh consists of multiple pathways of interconnecting devices and networks, so redundancy is built in with multiple connections. The internet is based on this topology, the most often used to connect networks to other networks. So this is what it looks like. It goes all over the place, so you can go directly, it's all over the place, so it's a mesh. So digital imaging communications in medicine, DICOM. So DICOM has become the most universally accepted standard for exchanging medical images. So it's layered on top of the TCP/IP, the most common network communication standard. So it has multiple layers. It's developed by the ACR and the National Electrical Manufacturers Association. And DICOM 3 is better than its predecessors for several reasons. So it permits the use of commercial hardware and software, requires strict content of the image header and the structure of the pixel data itself for each type of modality. So it actually has a header on it, which is nice. It requires a conformance system so that the user can determine from the vendor's documentation whether the device will operate together. It embraces an open standard of development between the vendors and uses users to come to consensus on the direction of the standard. So the standard is made up of 20 different parts ranging from image display to media storage. Now every device conforms to every part of the DICOM, so each device conforms to the part necessary to perform the task it is assigned to by the user. So the standard is maintained on a continuous basis and is published periodically, so they're constantly doing upgrades and fixing errors. DICOM standard defines the service classes or functions that a device can perform on a defined information object, so like on a CT. So allows the service object pairs, the SOPs, for a device are spelled out explicitly in the conformance statement. A device will perform as a service class user, so the SCU for a given service, an object for a service class provider, so the SCP or both. So the SCU and the SCP are commonly referred to as roles. So the network communications in DICOM are always between the SCP and the SCU. Most common service class seen in modalities and packs are the following. So we have the image storage, the query and retrieval, the print, the modality work list, modality performance procedures, the storage, and the interchange media storage. So here's a good example. MRI scanners conformance statement lists the MRI image storage SOP. So retrieving the PACS archive list in the MRI image storage SOP class and the SCP role, the MRI scanner would be able to send images to the archive based on those statements. So if either statement does not support the proper SOP, class, or role, the transfer would not be possible. So basically what this is saying is that whatever, it has to be in a DICOM language in order for the PACS system to work. So that way we can burn CDs, we can store universally. So that's basically broken down to what that means. So another aspect of DICOM is its specification on uniquely identifying each study, series, and image. So DICOM uses unique identifiers to globally identify each image set. So the numbers are created based on vendor number, serial number of the equipment, date, time, patient, or processing number, study, series, and image numbers. So a lot of problems we had when we first started using DICOM and saving images onto the PACS system. We still have some issues with it, but not as bad as we used to. When we would send a study in to the PACS system, and if we modified the study at all and wanted to resend it, we would delete it out of the PACS system, but we'd put it back through, but it had this unique study ID that was imprinted on the images. So when we sent it back in, it would always save the older one. We could never overwrite it with the new one. So they have gone back through and fixed it. So it used to drive us crazy because I'm like, no, we saved the new one. Why is it the new one there? They kept recognizing the old, even though we deleted it. When we delete things, things don't really get deleted. So it was still in the memory. So it kept putting that study back in because of these unique user IDs, unique identifiers. So DICOM also provides a framework for the use of compression. So we usually store things as the joint photographic editors group, so JPEG, lossy compression of 2:1. So most common compression technique within hospitals. So no image degradation results upon viewing after compression. There are, when moving images outside the hospital, which we usually store off campus, lossy compression may be necessary to suit external networks, and we have some image degradation when we do that. When we bring them back up, they're not quite the same detail. When a modality supports the service class of the modality work list management. So the patient demographics can be pulled directly from the RIS. The RIS can interface via DICOM or through gateways that creates an interface with HL7 device and the DICOM. So HL7 is the hospital system. So that's the HIS, Hospital Information System. So the HIS and the RIS have to work together with the DICOM. So we've got 3 different things going on. So the DICOM goes into the PACS. So they all have to talk and play nice in the sandbox. If one goes awry, we're all cooked. So HL7 stands for Health Level 7. Is used in most healthcare applications such as devices, imaging, insurance, pharmacy. So any kind of billing really that we do, we do this HL7. It consists of many parts and is used at many levels at various hospitals. So you'll hear just the HIS. So the standard generally used in communication between the hospital information system and the RIS. So the HL7 is the connection between the two. So the HIS holds the patient's full medical information for the hospital billing to inpatient ordering system, where the RIS holds the radiology specific patient data. So the electronic medical record, the EMR, is part of the HIS or runs along with it and contains all the patient's records. So the PACS have also begun interfacing with the EMRs to present images to referring physicians through the same common system. So when the doctor's in the ER and he's able to pull up the patient's images just within the patient's medical chart, that's where the HIS, the RIS have DICOMed into the PACS, and the PACS is now communicating with the EMR. So it's a very complicated system, and there's a lot of places where it can go wrong. All right, so here's your summary. We've come a long way with computers just in the basically 20 years that I've been in the field. We didn't have any computers. We actually used typewriters to put the patient's name on 3x5 cards, flash cards, and now it's all computerized. It's very fun to watch. It's very complex, and there's a lot of places where it can go wrong. And if you have the general basic foundation, you'll be able to explain to the IT people, or you could be the person on the other end, the IT person for radiology. It's a great field. It's growing like crazy, and having people that know what they're talking about is vital. Okay, thank you. Study up.